everyone. Welcome to the latest in the GeoTalks Express series. Today, as you're seeing on the screen, we're going to be talking about point cloud data. Specifically, we're going to be looking at various methods you can use to improve the quality of point cloud data. We're going to be exploring some of the tools within the Lidar module to create a better point cloud for whatever analysis process we're going to be using that for. For today's presentation, I'm joined by my colleague, Billy Noble. Good morning, Billy. How are you?
Good morning. How are you, David?
I'm great. So Billy and I will be tag teaming, going through a number of workflows, exploring some of the tools, and again, showing you how you can improve your point cloud data. Before we get started with our presentation, before we get started with the kind of hands-on part, a few housekeeping issues that we deal with. I know many of you have attended previous sessions. Hopefully there are those of you for whom this is the first presentation you've attended. And for those who are new, just a few reminders here. You are in listen-only mode during this webinar. Hopefully you can hear me, you can hear Billy. Unfortunately, you can't speak. We don't have that option. If you have questions, and I hope you do, you can throw those into the questions panel over there on the right side of your screen. You'll see that GoToWebinar tab, or the GoToWebinar panel. In there, there's a little tab for questions. You can pop that right out and you can ask whatever questions you want. We will try to answer questions in the appropriate context when they're asked about the topic at hand. If the questions involve something a little more in-depth, we may take those offline and we will follow up with you and answer your questions specifically or in more detail on an as-needed basis. Also, we will take the questions that were asked and publish them in a blog. That usually takes a few days, but we'll send you a link to all of the questions and hopefully all of the answers as well. In a few days, you'll get that information. The session is being recorded, so you will have a chance to revisit this. I know many of you are probably watching the recording. Unfortunately, if you're watching the recording, you don't have that live question and answer opportunity, but you can still ask questions. I will share an email address with you, or it will be in the description right down below, where you can send any questions about this topic or about the areas of global map what we're going to be covering today. So again, just a few housekeeping issues before we get started. We have a couple of additional GeoTalk sessions arranged. Next month, July 21st, we're going to be working with a partner company that is using the Global Mapper extension. They've actually developed an extension that works in tandem with their software. Now, for those of you maybe interested in exploring the Global Mapper SDK, this is a great opportunity to see how that works. They're going to be doing a little demonstration of that tool and how their application works in tandem with Global Mapper. It's a very creative use of the Global Mapper extension. Moving into August, we're very excited about this one. We're going to be introducing the latest release of Global Mapper, the preliminary information. The release is actually scheduled for the following month, but we want to give you a little sneak peek. Global Mapper is going to be changed, the structure is going to change. We're going to be introducing a professional level of Global Mapper. Some of you may have seen some of that information already. In our August presentation to, again, kind of lay out some of the plans, we're going to be introducing version 23, and we're going to give you some information as to what's in store. More information about these upcoming presentations is available on our website. You'll see the URL here. You can register now and sign up and attend any of these live presentations. Also want to mention a little bit about our training opportunities. We are in the middle of a training class right now. We're delivering a Global Mapper class as we speak. Next week, Billy and I are actually going to be doing a Lidar class. Now, I want to kind of plug that one in the context of what we're going to be covering today, because obviously today we're going to be dealing with some of these tools in at a very superficial level. If you want some more information and you want to see these tools in a more practical hands-on context, you can sign up for that class next week. I don't have it on my bulleted list, unfortunately, but June 22nd, there is still space available in that class. It's a 3-day class. It's in the evening here in the US East Coast, early evening for those in the West Coast, North America. Those of you in the Far East, maybe Asia, Australia, New Zealand, it will be a morning class for you. So take a look at the website. Again, I'll bring up the URL in a second. And again, if you're interested in finding out more about the tools we'll be exploring today, then by all means, you can sign up for that hands-on workshop, hands-on class that we'll be hosting next week. After that, we're going back to training on Global Mapper. You'll see the next scheduled class is July 26th to July 30th. That's a 5-day class. We have 3-hour increments. This is an online class. Again, it's hands-on, it's interactive. If you're interested in exploring Global Mapper, some of the tools in there, you can absolutely sign up for that. And again, we're repeating our Lidar class in August as well. So if you're not available next week, you can go ahead and sign up for the August Lidar module class. It's a very popular class. We explore all aspects of the Lidar module, including our pixels to points tool. Those of you may be familiar with that photogrammetric tool. So your information at the website here, bluemarblegeo.com, GIS training. You can also go to Blue Marble Geo and explore the education section and find out more about that. Today, what's our topic? What's our focus? Well, we're going to be talking about improving LiDAR data. And there is a little bit of a cliche that you often hear batted around, that the quality of any output product is very much dependent on the quality of the data you input. And that's what we're going to be addressing today. In past presentations, we've looked at Global Mapper's terrain analysis functionality, at the ability to extract features from a point cloud. To get to that point, obviously, you have to have some source data. And if that source data is in some way deficient or inferior, you're going to run into issues. The quality of what you derive from that is going to be of an inferior quality as well. So what we want to address today are the tools that are available in the Global Mapper LiDAR module that allow you to improve that quality. What ways can we improve a point cloud? Well, we're going to divide these into 2 basic sections. The first section is going to be editing. We're going to explore a number of workflows where we'll retain the points within a point cloud, but change them in some way. And there's a number of ways of doing that. Billy and I will be switching back and forth to show you different ways of editing a point cloud. Editing may be simple manual reclassification, selecting a point and changing some of its characteristics. Billy's going to show us how that works. You can do that from multiple perspectives: top-down, profile view, even 3D view. That selection and reclassification can be initiated using multiple components of the software. We'll also explore some of the automated tools, looking at the geometric characteristics of your point cloud, perhaps for determining which points are ground. Again, thereby improving its quality. Rather than having unclassified points, you will know which points represent bare earth for the purpose of maybe generating a DTM. And we'll explore a couple of those tools as well. Some more specifics. We'll add color to our point cloud. Again, these can be captured in the data and ultimately used to generate a better point cloud where you have color values embedded in there. We'll talk about moving a point cloud. You may encounter point cloud data, LiDAR, or maybe photogrammetrically generated point cloud data where the point cloud is incorrectly positioned. And we have a number of tools that will allow you to correct that, offset that, both horizontally and vertically. And I think Billy's going to go through an exercise where we'll do a QC process where we offset the point cloud to reflect ground control points that we've collected. As well as editing, we're going to be talking about filtering. Now, editing, as I said, retains the points in your point cloud, but changes them in some way, changes their characteristic, position or classification or various other variables. Filtering removes points that we don't need. And obviously, there's a number of tools that will allow us to do this. Filtering by extent is perhaps the most common. I don't want this full point cloud. I only want a small subsection reflecting my project area. And we're going to take a look at how we can crop a LiDAR point cloud or a LiDAR or point cloud to a defined area. And we can filter by classification. I only want my ground points, or I don't want my ground points. I want my non-ground points. The deliverable product may be a subset of your data, which removes the points that you don't need. And that's a very simple process. We'll talk about that filtering. More specifically, we may want to address points that are considered noise. Noise being points that are beyond the expected threshold, vertical threshold within your point cloud. It's quite common, and we'll actually see an example. I picked a point cloud randomly to illustrate this, and I saw noise points that are both above the surface and below the surface. Those can be addressed using an automated tool and identified, and if necessary, filtered. Remove those for whatever workflow you want to apply your point cloud to. Thinning is an important one as well. If you have a very high dense point cloud and your intention is maybe to generate a DTM, you may need to remove some of those points. The quality of what remains after you thin is going to be dependent on the specific application. You can thin by retaining the lowest elevation point or the highest point or the average point. And again, it will depend on how you intend to use your point cloud, how that thinning process is applied. Again, Billy's going to be going through this exercise to show some of those point cloud thinning processes processes, again, also as a process of filtering, you're moving a little bit of the redundancy in your data. Filtering by selection, this is a very simple one. You just simply want to grab some points and initiate some sort of filtering to remove the points that don't match the criteria that you are interested in focusing on. So again, kind of for convenience, dividing these two sections into two, editing, filtering. There will obviously be overlap. There are editing tools that in effect are filtering. There are filtering tools that require some sort of editing. But in order to kind of understand this at a higher level, we'll take these from two separate perspectives. To wrap this session up, it is worth acknowledging that we can also export a point cloud. The improved point cloud, whatever procedure we follow, whatever improvements we apply, can be assigned to a new point cloud. And for many folks, that's the deliverable. Yes, it's likely that you want to take that point cloud and analyze it, or create a DEM or something of that type, but you can simply output that data in a point cloud format, in a Lidar format, and deliver that as your deliverable. So in that sense, Global Mapper's Lidar module can be considered a utility for data improvement, and that again is what we're going to be focusing on today. Now, before I hand over to Billy to go through that manual process, I want to do a little bit of a kind of housekeeping overview. I'm going to bring the software up here, just a quick look at the layout here. Now, for those of you not familiar with Global Mapper, the component that we're going to be looking at specifically today is an add-on component called the Lidar module. The visual representation of the module is an array of buttons you're seeing along the bottom of my button array. Now, we're going to be touching on a number of these today. If you're new to Global Mapper and want to explore this, you can first try the software itself. You have the option to download and initiate a 2-week trial. You can also try out the Lidar module. I want to show you where you can do that. From the help menu, there's a license manager. If you're using Global Mapper already and you don't have the Lidar module, you can do this as well. Select that option. You'll see the Lidar module option here. Go ahead and check that box. Follow the prompts, choose the trial option, and you can basically use the tools that we're about to explore today for a 2-week trial to let you see if this will work in your workflow for improving your data. So again, if you're not using the Lidar module and you want to explore some of these tools in a little more depth, then absolutely go ahead and grab that trial, 2-week trial, and you can use these tools. So again, back to my list here. The first thing we're going to do is take a look at some ways we can manually improve the quality of our point cloud by assigning updated classifications. Now I'm going to change the screen presentation over to Billy so he can take over and guide us through that process.
Yep. Great. You can see my screen, David?
I can. Yes, I can.
Great. Yep. So today, to kind of get started with improving a point cloud, I'm kind of going to go over some of the simple methods of just editing point cloud data and information. So here you see that I have a Lidar file. So you can see in the control center, this farm, it's an area of, I think it's in Vermont, of aerial collected Lidar. It's a LAS file with about 6 million points. So sometimes you get maybe some misclassified data initially from maybe you download it online somewhere, or maybe a vendor who just provides the data and actually didn't go through any editing process, but has some classifications right here. So as you can see, I have the brown this Lidar. I'll just open the 3D viewer to show what we got here. So all the points that are classified as ground are brown, and we have points that are green are classified as vegetation. So obviously this data set needs some work. We have a lot of unclassified points in our trees and forests here. I have a couple buildings that are here. You can see this is the barn that we'll be taking a look at today. But if you can see in the 3D viewer, it's green. That's obviously not vegetation or a tree. This is a barn building. So I'm going to go back to the 2D viewer and kind of show how to select this and change the classification back to something that would make sense, which is building. So like a lot of our digitizing options in Global Mapper, you start with the digitizer tool in the toolbar. and just select the features that you're interested in. So if I want to go ahead, I can just select one point and right click and go to the edit point feature option here in this right click digitizing menu. And you can see that we have the options to edit some of the attributes of this one point. So I could go in and change this point to back to unclassified, or I could give it the actual classification that it should rightly have, which is building. And you also have other options as well to adjust the elevation, its intensity, or some other attributes as well. But for this, I'm going to switch it to building and click OK. You probably can't see that, but it did change to orange. So I just selected one single point there. I can also grab a swath of points, just clicking and dragging on my screen. As you'll see here, when I go back to the right click menu, now it's editing multiple features. So this classification dialog has multiple LiDAR types selected because I'm grabbing some building points, I'm grabbing some vegetation points, and some unclassified points. But as the same thing with just the single point, I can click building and click OK. I'm going to also do the same thing with these other points as well. But I'm going to introduce you to some of these buttons here. So this is the LiDAR module toolbar editing buttons here, which is enabled if you have the LiDAR module as part of your Global Mapper package. So I can just manually select one of these options to change the classification of all those types. So if I clicked ground, they would turn brown, vegetation, they would turn green, and so on. So manually editing each point using the buttons here. So there is a classification button for a building. So if I just select that, you're prompted to choose what, or prompted to confirm changing the points. So click yes. And if I want to deselect the point so I can see that they changed, I click the clear selection button here in the toolbar near the digitizer. These are changed to orange. So that is just a simple workflow showing how to manually edit points using the digitizer tools. If I go back to my 3D viewer, I can also use the selection options in 3D to also do the same thing as well. So I was playing around with this a little earlier. I see I have some power lines that are classified as vegetation or unclassified. So I'll actually zoom in towards this area. Let me go back out. Scroll, scroll, scroll. And if I go down a little bit, I can actually select a swath of LiDAR points using the digitizer toolbar in the 3D viewer. So that's up in the top menu here, digitizer mode. And I can now drag select and select LiDAR points, which is kind of a newer function in our 3D viewer. These are recent versions of Global Mapper. If you didn't catch that, the points that are just darkened are not selected. So the ones I had selected stay in their color as this gray, and actually clear selection to show that again. So you see the other points that aren't selected darkened. So if I right click, actually, sorry, I'm gonna dock this here. So I have my points here. And I'm going to edit selected features. And I get the same dialog box that I had open in the 2D viewer. I can change these to wire conductor. Click OK. And now those will change to yellow. So that is the 3D option. Just to note here, when you're selecting in 3D using the swath selection, a lot of the features behind will get selected as well. So if I do this again and select some trees, you'll see that it kind of shoots a kind of cone-like selection at here. So it's good to make sure there's nothing behind where you're selecting. So it's very good for open trees and structures like this as well. So just keep in mind when you're working in the 3D viewer.
Billy, there's a question came in about profile view. I think maybe it's a good idea to quickly show this as well. I mean, obviously what Billy's showing us is a manual process and maybe not practical, but it just illustrating the idea that Global Mapper can be used to select one or more points, depending on how you can initiate that selection process, 3D or 2D, and then manually assign them a new classification, or indeed any of the other characteristics. But perhaps, and again, Billy's quickly going to address the issue. The question that came in is the profile view. Drawing a cross-sectional view across a section of point cloud will display those from a lateral perspective. Now, again, without going into the details, that pink area that you noted on Billy's screen is actually a swath. Rather than defining a single line feature, which is what you would typically use when profiling terrain, we're defining a buffer area. So again, quick glance down at the window down below shows you we can now isolate those elevated points, making it much easier rather than top-down view or even 3D view, isolating those points specifically for the intention of manually assigning a reclassification. And obviously in this case, we would probably widen that swath a little bit so it encompasses the full extent of that building. So again, manual reclassification, definitely an option from a practical point of view, maybe not the best option for many of these workflows. Well, I don't know if you want to show maybe a slightly different workflow where the selection process is not manual. I mean, in this case, Billy manually used the digitizer, either 2D or 3D, to choose the points for the purpose of reclassification. Maybe you want to initiate a process whereby you're selecting points using existing vector features. In other words, all the points that fall within a specific extent can be manually reassigned. Miraculously, quickly, we've changed our location here. Just quick geographic perspective. This is the city of Portland, Maine, in our neighborhood here. It's a little bit further south than where we're sitting. And we've got a point cloud. Billy, I'll let you take from here what we're going to do with this workflow.
Yeah, so I have, so hide my Lidar point cloud in my imagery, I guess my shapefile as well. But yeah, so in this data set, I have building outlines in Portland. I want to use, select all of the vectors here to define the bounds of where I want to classify buildings. So if I go back, turn my Lidar, a lot of the areas that are gray are unclassified, but we know those are building features, and we can use the vector to kind of isolate where I want to change the classifications to buildings. So to start this, I can select all the features of the shapefile here by right-clicking in the control center. Just going to select all features in my digitizer tool. So if I zoom in a little bit, you can tell that the hatched areas are where I had selected my vector features. And so then what I want to do is do an advanced selection option just to select Lidar. And so this option you can find in the right-click menu for digitizing. You go to Advanced Selection Options, and I'm going to select all points within selected area features. So give this a minute, or hopefully not a minute. And as that's spinning, it should be grabbing the points within those building outlines. And it did so as marked in red. And I can do a little more advanced filtering here, or advanced selection. It's the proper term to classify the building points that are above a certain elevation. So I can go to Advanced Selection Options, Filter Selected Lidar Points by Elevation. You can see that I can already set this, but we have options to filter LiDAR, to unselect LiDAR above a certain elevation or below as well. There are also more advanced filtering options on the right side here. But what I want to do is keep the building points above 3 meters. So you'll see some points get unselected. We'll note, I think this area right here that I'm circling has points that go right up to the ground. So you'll see those get unselected. So let's click OK. As you can see here, those got unselected below that threshold. Now I can use the building classification option in the toolbar. Click yes. And I'll deselect the points to see those change, and they should have changed to orange. And yes, they did. So again, I was using the shapefile to define the boundaries of my selection to reclassify the LiDAR.
Yeah, and I should say for that workflow, yes, this is manual. I mean, we wanted to introduce some of these manual tools. Again, there may be a more practical application or practical component to this reclassification. In fact, what I'm going to do in a few minutes is show you a way that we can analyze the geometric characteristics of the point cloud to perform exactly the same thing that Billy just showed us. But the manual process is always there if you need it. And very often, you need to override some of those automatic procedures to do a little cleanup. And Billy showed us some examples of that. A couple of questions that come in, I'll just address them verbally. Someone mentioned a legend. Billy, if you wouldn't mind just going to the view menu very quickly here, we're not actually going to enable it. Right at the bottom, you'll see workspace layout options. Don't go any further, Billy, but right here is the option to display a legend. Obviously, if you're representing your points based on classification, you'll want to describe what they are, and that will allow you to enable a legend to show the point types that are included in there. Folks have mentioned about filtering for selection, removing points you don't need to enable the more simplified selection process. We're going to deal with filtering in a little bit. The idea of removing points you don't need. So your vegetation points, if you don't want them to have to be displayed in your 3D view, absolutely you can filter those. Hold that thought for the time being. We had a question about adding color, Billy. I think you're going to be doing that one in a few minutes as well, where we're going to update the point cloud to reflect the colors that are in an underlying image layer. So yeah, hold off on that one for the time being. Someone mentioned about cutting overlaps. It's a good question, not something we considered in the context of editing LiDAR, but you're right, it is actually an editing tool. Billy, if you would show very quickly from the analysis menu, there is an option, fourth option, to find the overlap. Fourth option from the top, find overlap between LiDAR arrays. Again, not something we're going to do right now, but if you want to explore how this works, this will identify those overlap areas if you've got flight lines. Again, perhaps for the purpose of initiating a filtering process, so you address those specifically. So a few other questions we'll address. I think some of the other questions are going to be answered in the context of some of our additional workflows. So I'm going to grab the screen, Billy. Thank you. We'll be back with Billy in just a second. And we're seeing another point cloud here. Obviously, the issue here is fairly apparent. Or hopefully, it's fairly apparent. This is a sample of some downloaded LiDAR data. This is publicly available here in the US. We can download this from the USGS national map. And when I downloaded it, this is what I encountered. And again, with apologies, I don't have a legend displayed. You're going to have to take my word for it. We have 3 classes present here. We have ground points, the brown. We have gray points, which are unclassified. There could be building, could be trees, could be any other type of point. And then we have these blue points. The blue points I found out are actually bridge points. Somebody classified these overlap areas with a classification that is recognized as bridges. Now, I'm not sure that there are that many bridges in this area, so obviously this is an issue. We could simply remove these. That's easy, and we'll deal with filtering later. As I mentioned, we could simply take the points that are in this classification and delete them, reducing the size of our point cloud perhaps, and maybe losing a little of the concentration in these strips, these overlap areas. Or we could retain them and maybe apply intelligence to them, and that's what I'm going to do right now. First of all, and again, I want to quickly take a look at the metadata for the layer. We're going to be looking at this a couple of times in a few different contexts, but this is a very useful place to go to find out more about your data. From the right-click menu, I'm just going to go to metadata, number of pieces of information here, including the density of my point cloud, the point spacing. What I'm looking at specifically, what I want to find out specifically is what classifications are present. And this confirms what I already figured out. We've got unclassified, we've got ground, and we've got a whole boatload of bridge points, which I know are not bridges. I want to address this issue. If you ever encounter a situation like this where you have one particular class that you need to change collectively, there are a few ways of doing it. You could use a manual process like Billy demonstrated by first removing the points from the display that you don't need, select them all and change them. That would be one method. A simpler method is right here in the toolbar for changing the Lidar class. This dialog box allows you to choose from the currently available classes, which I know in my case is my bridge points, and choose which class to assign them to. In this case, I'm removing these incorrectly, or not removing, but I'm reclassifying these incorrectly classed bridge points. For now, I'm going to make them unclassified. We will address the process of automatic classification in a second based on what we generate here, but for now, I simply want to change these incorrectly classified points to unclassified. They are now available for me to identify other types of structures in there. We'll click OK, happens fairly quickly. Confirmation that 818 have been changed, and you'll see that visually now. Those blue points are now gone. If I went back into metadata, that classification would no longer be listed. So that's an example of manual classification, but based on the presence of maybe some erroneous classification within your point cloud, and it's a very simple procedure. We're going to move away from this manual process. Again, I said it's probably not very realistic for you to manually select points as Billy showed us and change the classifications. Maybe for a little cleanup, the building, for instance, it might be useful, especially using the profile tool. But what's a much more useful procedure for improving the point cloud is to initiate an automatic classification. And this really forms a foundation of many of the Lidar module's significant functions. Right here in this little toolbar, there are multiple tools for identifying specific types of points. Someone asked a question about an unclassified point cloud. Absolutely, if you have a point cloud that was generated photogrammetrically that has no classifications, the first thing you'll likely want to do is run this process to identify ground points. And I'm going to do it right now because I know based on the points that I have identified as unclassified, it's likely some of those are ground. And I can run a geometric analysis. I'm not going to go into the detailed settings here, but I can run a geometric analysis of the point structure and hopefully extract additional ground points from this point cloud. I'll just run the process. I'm not going to deal with the details. By the way, if you want any more information on how this works and the settings, you're going to have to sign up for the training class next week to get more information. But suffice to say, when this process completes, you will see I have been able to pull out additional ground points here. If I'm interested in generating a DTM, I have more points to work with in those areas where the points were incorrectly classified. And again, at this step in my workflow, I may export this and have a better quality point cloud that I can deliver to my client simply by running through that automated reclassification process.
Hey, David, there's a good question here. So when you change these classifications, they're not permanently changed yet, correct?
That's a great question, and it's a very appropriate question. Yes, what I've changed is just Global Mapper's perspective of that source data. I haven't changed the source data itself. This is an external file that I had loaded. That external file is still in its present form, or its original form. Global Mapper does not make changes to the original file in real time. The workflow, and we will conclude with this at the end of our presentation today, the workflow that we need to initiate is to export this data to a new file to preserve these settings. Yeah, so we actually had two questions on the same theme from two different people. But yes, the raw LAS or LAS file, somebody mentioned the raw file, has not been changed. If I loaded up that file again, or if I sent it to Billy and said, have done my work, he's going to say, no, you didn't. It's only saved internally. Now, Global Mapper can save that locally by saving what we call a workspace. I know many of you longtime Global Mapper users will be familiar with a workspace. That will allow me to pick this up tomorrow and continue to work with it. But it, again, does not have any effect on that external file. Hold that for at the end of our presentation, and we'll talk about the export process. I want to go through one more automated reclassification or automated improvement. And again, we're on the umbrella of point cloud improvement here. So I want to talk about improving this data even more, because we have a significant number of points that are currently unclassified. We don't know what they are. They could be buildings, trees, they could be people, they could be cars, they could be a bird flying in the sky. Global Mapper offers a number of options for identifying additional point types within a point cloud. And again, it's a geometric analysis. Depending on your point cloud, depending on what you're looking for, you can look for things like power lines. Billy did that manually for us, but if I had actually going through that workflow, I can automate that process. I can identify power lines based on their geometric structure. I can identify buildings and vegetation. I'm actually going to run through that one very quickly. Ultimately, we can extract those as vector features. That's not what we're doing today. We're simply talking about improving the data. So I'm going to run through the process very quickly. Again, without dwelling on the technical details, there's a couple of different methods we can employ for doing this. Want the details in this, again, a little plug for our training next week. We'll cover the details. With the settings such as they are, I'm going to click OK, and hopefully within a short time frame here, we should see a couple of additional colors added to our display. It will identify within these unclassified points which are high vegetation, trees, and which are likely to be buildings. And again, in this context, I can take this data and export it. I have now added intelligence to this data that was not there in its original form. If you think about how I first presented this file with those bridge points, well, they're gone. I fixed that issue. I also improved the quality of the point cloud by identifying additional point types. And I could do a little manual cleanup. Classic example right here, right in the middle, where it's identified, maybe a little further right, you'll see it more clearly, a bridge here. That is obviously not a building, but structurally it looks like a flat roof structure. We can do some manual cleanup to improve this as well. So the combination of automatic and manual reclassification will allow us, in a collective sense, to improve the quality of our point cloud. We have a question that asks, so these are all very appropriate, they're leading into some of the workflows we will be covering. Can we identify noise? Yes, we can. There's a tool right here for looking for low and high noise points. I will show you this in just a few minutes, so hold that thought for the time being. A couple of additional reclassification or kind of improvement workflows. Billy, I'm going to hand over to you maybe to demonstrate these. This is based on a question that we were asked a few minutes ago, the idea of adding color. Very simple process. Billy, if you want to maybe guide us through how that works and maybe adding some additional attributes to your point cloud to improve its quality.
So in this workspace, back in the Portland workspace, I have just the image layer currently opened right now. But I still have that Lidar file. So to answer the question from earlier, how do I apply the kind of the orthophoto RGB values to my point cloud? So if I open up the point cloud again, you see color by RGB / ELV. If it doesn't have the ortho photo information yet, or the RGB values in the points, it defaults to this color scale with the it's just classifying or coloring the Lidar by its elevation. But you can quickly apply the attribute of the photo using this tool called Apply Color to Lidar Points. So if I selected a point now and looked at its feature information, there's no information about red, green, blue yet, but you'll see that in just a second when I run this tool. So click Apply Color to Lidar. Since I only have the one Lidar or Lidar data set here, that's the only layer to update, and I only have the one image to get the values from. So there's different selection options for RGB color, or if I had near infrared, I could add it as well, but this is just a RGB photo. And just leave all those other settings. I will click OK. So it quickly colorizes the points, updates 2,900,000 features. And clicking OK here, it changes the look of the Lidar. So color Lidar or RGB / elevation now uses the RGB values. So if I click that same point, I think that's the same one. You'll see in the feature info, we have additional information embedded in its attributes. So it's red, green, blue, and also just the RGB 3 values noted here. So if I uncheck the Lidar or uncheck the imagery in the control center and zoom out a little bit, you can tell now that these have been applied. You can also check this in 3D as well to get a better rendering of the point cloud. You can tell the buildings here. So yeah, just a couple clicks and you're on your way to applying orthophoto RGB values to your point cloud. Any questions on that? Or
yeah, I think this was a question that was asked previously. Maybe Billy as well. Again, we're going to have to speed up a little bit here because I know we're quickly going out of time. But another attribute you can add to a point cloud is the height above ground. Now, obviously, every point in a point cloud has a Z value or a Z value. It's an elevation value. You'll notice here where Billy's going in the dropdown, we have the option to reassign the visual characteristics to represent height above a local ground surface. It will actually generate this dynamically. It's obviously not embedded in the file. Billy, if you go ahead and select this, you'll notice the visual characteristics change. Now we have, based on the same elevation shader, but with the colors are now representing the local height, the height above a local ground model. That value is now added. We now have an additional attribute. Look at all the additional attributes now we have applied to this point cloud, including that attribute. We have the original elevation, but we have an additional value. And these, again, are going to be embedded in the point cloud you generate, will be retained when you initiate that export process, as we'll demonstrate a little bit later. Okay, again, I'm looking at the clock here and we have a lot of stuff to cover. So let's continue on the theme of editing your LiDAR, modifying its characteristics. One of the important ways you can modify LiDAR, obviously we've talked about changing some of the attribute structure, but you can also shift it. You can also move it. And there may be situations where the LiDAR just doesn't line up either on a vertical, in the vertical context or horizontal. And I'm going to show you very quickly a very simple tool for addressing the latter. I'm going to focus in this example on maybe something that's fairly recognizable. We have a building outline here, at least a component of a building, a partial building that I identified. If I turn on some underlying imagery, you'll see that it doesn't quite line up. Now, I have to say, I staged this for effect. You may encounter this type of issue where the point cloud, for whatever reason, just doesn't line up with underlying data. There are a number of ways you can correct this. I'm going to show you one very easy one. Now, obviously, in this case, we know it's a specific offset. We can measure the offset distance, we can measure the bearing, we can determine what that is. I've done that already. I simply want to shift the entire point cloud in a specific direction by a specific distance. I can initiate that process by right-clicking and going to shift. Now, there are a number of options available in this tool, this dialog box to simply shift the layers a fixed distance or to apply some sort of transformation. This gets a little more involved in terms of reassigning the position based on a transformation algorithm, but we're just going to shift them a fixed distance. And again, within this, we have a couple of variations on this theme to shift them relative to the X, Y, and or the Z-axis or Z-axis, or you can just horizontally shift them. And just glancing at my notes here, making sure I'm doing this the right way, we're going to move these. I think I did it before, so it's retained the settings. I'm going to move them a distance of 5 meters on a bearing of approximately 280 degrees. Hopefully the edge of my building will line up correctly. It'll take a little bit of just a second to move. It's a little bit better, maybe a little bit more of a shift, but needless to say, that was again a manual process, a manual update to my point cloud to move it to correspond with some data that I have more confidence in that sits underneath. Another process you can initiate, which is more involved, is to rectify the point cloud. Now, rectification means assigning recognizable points within your point cloud. You literally can select a point and determining where that point should be in three-dimensional space. I'll quickly show the dialog box. You may have seen this in a different context. You may have seen this dialog box in the context of image rectification. But now that we're dealing with a point cloud, we can do something similar, except when we select a point, and we obviously would recognize a specific location of an actual point, it tells us where that currently resides in three-dimensional space, and we can update that. Both X, Y, and the Z or Z axis can be modified for that point. Repeat that throughout the extent of your point cloud, and not only will it shift, but it will also rubber sheet or align the points more correctly based on this rectification process. So a little more involved in a specific shift. This rectification tool lets you adjust those characteristics horizontally or vertically as needed. Now, I'm going to hand over to Billy once again, because there's a couple of additional tools that can be used to adjust the locational characteristics of the point cloud. I think you're going to go back to the that photogrammetric point cloud again, Billy.
Yep, so I'm back here with my photogrammetric drone-derived Lidar data set here, but I've also added kind of the farm data that I had originally shown in my first editing workflow. So along with some of the other tools, we also have this option to fit point clouds together. So I'm not going to actually run through this process, but just to show you that these two Lidar data sets are actually not lined up perfectly. I can just drag a path profile, and I can show you in this profile view. You can see that the one with the color, the accurate photo color, is the one that was derived photogrammetrically. Oh, always tough word to say. And also the one that is colored by the color shader is the one that was derived from aerial lidar. So if I go ahead and go to fit point clouds together toolbar button, I can choose which point cloud to compare against and which one to adjust. I would probably adjust the point cloud of the photogrammetrically derived one to the LiDAR, as it might be a little higher accuracy, because I have some of my my drone is a little inaccurate in the z-value direction. But there are options to automatically fit the point clouds together. I'm using the various options in this tool. Or if I had select control points, I could do that as well. So if I clicked OK and ran through this process, you would see the adjustment to my LiDAR. But I'm actually going to show you, actually I moved into the Lidar QC tool, which kind of also incorporates vertical adjustment by using ground control points. So I'm going to hide this layer and turn on a layer called ground control points.shape. So these control points are just a few meters off from the LiDAR, but if I had a surveyor go out, these are actually more accurate Z values than the point cloud itself. So I can look at the values by going to right-click the attributes, just pulls it off screen. But I see the elevations are listed for each of the ground control points here in my workspace. So Lidar QC tool, what this is doing is it's adjusting the point cloud, those localized areas with the elevation values to those the control source. So what the control source in this workflow is my ground control.shape that had those elevation values that I had shown. And I'm going to be comparing against the generated point cloud, the Jubilee farm file. I had set this up, and I think I will use meters. I think it was, David, correct me, 5 meters to specify the maximum distance from the control point to look for. And this is a pretty dense point cloud. And what I would want to do is enter 20. So I'm not going to click OK here. Actually, I'm not going to click OK. Sorry, I'm ahead of myself. So when I click OK here, you kind of see the elevation difference within those localized areas around the control points. It shows the elevation difference. So one of these points is pretty high, 5 meters, but just a couple meters on these other ones as well.
Yeah, so this is a procedure you would initiate if you had forgotten or had not assigned ground control when collecting the data. Again, this was drone-derived data. Typically, you'll send out a surveyor, determine your ground control locations. They're captured in the images, and Global Mapper will factor those during the process of actually generating the point cloud. What Billy demonstrated here is a post-process where you can send the surveyor out. It doesn't necessarily need to coincide with a specific location, just the localized ground that you know based on the elevation value. You determine that from those ground control points, it interpolates a shift If Global Mapper, or if Billy, if you just click that button down below, fit LiDAR to point clouds, or fit LiDAR to control points, it will offset the LiDAR in an interpolated way to match those measured values. This is a post-process rectification tool that corrects those Z values. So definitely have that option. Now, again, we are going to quickly run out of time here. Let's shift our focus.
I'm just showing my adjusted point cloud really quickly. So that was the 2 results, so I exported it.
Yeah, excellent. So you shifted, you moved it so it matched what you measured. Absolutely, the before and after. Thank you for that, Billy. I want to grab the screen back again because we're going to shift to look at filtering, and this is obviously a very simple process. Now that we've identified through some sort of modification to the characteristics of our points, which are points that we don't need to retain, we can apply filters. We can modify points as needed. Now, from off screen, I'm simply going to drag in a point cloud. You'll likely have seen this before if you've worked with any LiDAR data in Global Mapper. I want to bring this up simply because it does give us the option to apply filters. These are variations on the theme of filtering. Filtering by classification, filtering by extent. We're going to talk about that in just a second as well. So multiple variations on the idea of filtering. Now, I typically recommend not spending too much time filtering your data at this stage. Again, we're just loading a file here. It's asking us which classifications to load. If I had initiated this process with that previous point cloud that I showed you, those bridge points would not have been included. I don't want bridge points, but I would not have known. So without some prior knowledge of the structure of your point cloud, it's probably a good idea to bypass these. Needless to say, all of the filters we can apply during import, we can also apply later. So while you have this ability, it's sometimes a good idea just to click OK. Now, perhaps the one that you may want to apply is a geographic filter. And again, Billy's going to show how we do this after the data is loaded in just a second. But only the point clouds within a defined area may be an option. I'm going to go ahead and load this one because the next stopping point, once you have loaded some LiDAR data before you initiate any type of filtering, is to look at the metadata. Again, I've been here before, but it's worthwhile as a first stop. Now I have my point cloud in place. What's included in here? This is where we can explore some of its characteristics, its density. Is it a high density point cloud? Is there too many points? Are there too few points? And the statistics giving me a breakdown of what classifications are currently present. Again, a lot of ground points here, some unclassified. I've got some low, medium, and high vegetation. Now I have the information I need to perform whatever filtering processes that are relevant. I'm going to come back in a minute. There has been some questions on things like noise identification. I'll come back in a few minutes and actually look at how we can identify noise in this point cloud. Before I get there, I want to revisit one of the tools that Billy showed us for that was used for selection and editing of points. You know, remember Billy selected some points using the profile tool for the purpose of identifying points that maybe were misclassified. That tool can also be used for editing, for filtering, for deleting points that are not necessary. I'm not going to take the time to do this, but we could create not just a single profile through my point cloud, but a series of parallel cross-sectional lines. There's a perpendicular profile tool that allows you to essentially navigate through your point cloud sequentially, identifying those cross-sectional views based on a defined swath, allowing you to very thoroughly look for anomalies and literally delete them right there if you need, those points that are too high and too low. Now, again, that's a manual process, but that profiling tool can be used as part of your filtering effort. You can also very quickly and very easily select points that are above or below a certain elevation threshold. I'm going to select a section at random here to display in my profile view, but just to show you, if I wanted to select all the points that are above what I would expect, there is a tool for that right here. Select LiDAR above a line. Now, I don't think I have any points above this line, but if I did, it would simply select all of those points that are above my tree line, maybe birds. Having selected them, I can quickly delete them. That's a very simple process for initiating a manual filtering process using this simple selection process. Billy, why don't you show us very quickly the process of filtering geographically? And this is a common one. Again, we could have initiated this when we loaded our point cloud, but now that the point cloud is loaded, if we know or we can define the extent of what we're interested in, potential garden, I see here, that's a good scenario. We want to do some local analysis of the garden. You can draw a polygon or import a polygon to define this area and remove the redundancy of your point cloud by removing points that you don't need.
Yep, so as David said, I want to just analyze this little area, maybe create a surface model eventually of this potential garden. So I can go ahead and select, so use the right-click option in the control center for this layer called New Garden. So I isolate that polygon. So I'm going to use a cropping function, which is available in the digitizer menu to crop the features within this area. And I want to put this in, actually, I'm going to keep it in the same layer because I don't actually want the rest of these points. And the other features outside will be deleted. So I click OK. Begins cropping, and I have the points for just my garden. But I still have quite a lot of points within this area. There's still 789,000. Keep that number in mind. There's an option here to thin out some of the redundant points that I don't really need. I don't really need this precision for this area, so I'm going to use spatially thin LiDAR. So I'm going to use the generate point cloud here as my layer to operate on. And I have different options for thinning method. But since this is just a pretty flat area, I want to keep a minimum elevation. So the idea here is that within the point spacing that I'm looking for, each cell is looking for the lowest point to keep. So if I had used max, it's looking for the highest point in each cell when I'm running this. But there are other options as well. For this, I'll stick to minimum. I'll create a new layer with the thin point so I can contrast with the original cloud and click OK. So my generate point cloud is at the top of the list of layers here. I'm going to uncheck my generate point cloud layer. That was the original, which was the 789,000. And I'm left with point cloud, which has 95,000 features. So maybe a little bit smaller size to maybe export and share with a colleague.
Yeah, and certainly for the purpose of generating a very high quality digital terrain model, that's more than adequate. Billy could have gone to the metadata to look at the point spacing to see exactly what that point spacing is. We're down to still 35 points per square meter. That's way more than we'd need for a decent surface model. Okay. We are probably going to overshoot the top of the hour by just a few minutes. Hopefully that's not inconvenient for you. We have a lot to cover, obviously. There's a lot of tools that we want to introduce you to. So I'm going to show you, this is a question that came up earlier in our presentation, the idea of specifically addressing noise. I've retained the same point cloud that we looked at previously. This is the one that we quickly showed when we imported. We were, showed the profiling tool for doing some manual identification of points that are too high or too low. But if I look a little more closely at the 3D view, if we peek underneath here, I don't know if you're seeing this, but there are points. I know it's hard to adjust this accurately, but there are some points here that are obviously lower than we would expect. I know they're in here somewhere. There are points that are too low. There's also a few points that are too high as well. Maybe, there we go. We can see them quite clearly here. So yes, we could, again, use the method that Billy showed us and manually select them, delete them, or whatever we need. Or we can use an automated tool for noise identification. And that's what we're going to do now. This is one of the other buttons right here in this auto reclassification toolbar, auto classifying noise points. And again, in the interest of time, I'm not going to dwell on the particulars. We're doing a geometric analysis of offset, which points within an area are beyond what we would expect in terms of that threshold. One I want to point to specifically is I am applying a filter to identify noise that's either above or below a range of my ground height. I've given a little flexibility here, -1. Okay, we know there should be no points that are underground, but we'll at least offer that flexibility in case there's any genuine anomalies. 40 meters is the highest tree in this area. I don't have any trees that are taller. So all of my points should fall in that range. We can also define a variance from the local average within our defined area. I'll click OK, and hopefully this will give us results in real time. We can see them here in our 3D view. It will reclassify the points, of which there are 129 low points, 14 identified as high noise points, and hopefully when this refreshes, we'll see them now reclassified and selected, and hopefully quite clearly noted here in my 3D view. You can see those above ground points as one. That's likely a bird that was captured by the aircraft, and indeed a number below. I have no idea how these ended up. I don't believe there's any sunken wells in this area. possible, but unlikely. But needless to say, now that these have been selected and identified, or indeed any classification of points that you've identified in this way, you can initiate a filter. This is ultimately where we want to go with this section. How do I remove the points that I don't need? Okay, I've identified them. How do I get rid of them? Well, let me first unselect them and go to the filtering dialog box. Really, this is what you're going to spend most time, where you're going to spend most time when it comes to filtering. We're listing all of the classifications that could be present, as well as return types. Is it first return, second, etc.? This would reflect multiple returns per pulse when using Lidar data. But if I want to simply remove my low point noise and my high point noise, I can simply uncheck the appropriate boxes. Or indeed, if I simply wanted to retain a specific type of point, this question came up a few times in the questions panel today. If I want to retain just my ground points, you can uncheck all of the classes and just check what you need. I'll apply this, and we'll see now that's removed my vegetation, it's removed the noise, obviously, it's removed unclassified points. And I can now proceed with a surface analysis, a DTM generation, securing the knowledge that all the points I've retained are just ground points. So noise removal, again, very simple procedure as a first step, again, towards that filtering process. Billy brought this up a few minutes ago. I think I want to revisit that as our last quick look at a filtering tool. Let me again enable all of these points. There is an option to filter based on selection. Now, I'm going to manually select some points. Now, obviously, this can be done in a more methodical way. If you're targeting a specific area, maybe in Billy's case, he's looking at the garden he's identifying. With those points in their selected form, there is a way now to adjust what's selected, to change or modify the selection. Now, this is obviously a means to an end, because once you have filtered the selection, you can capture a subset of your data based on what you don't want to retain. This is a very powerful tool. It's a little bit hard to get to, a little bit hidden here. Once you've selected the points, right-click and advanced selection options all the way at the bottom, filter selected Lidar points by whatever variable. Billy talked about this briefly earlier. You can retain points based on their color value. You can retain points based on a scan angle or density, local density within that area. It'll show you the available ranges in this point cloud right now, but you can again adjust which points are selected based on whichever variables you want to. Maybe I want to isolate just my buildings. I can do that using this as well. I'm not actually going to apply, but assuming I had, this select list would have a subset. If I want to capture this, if this becomes my end product, Control C, Control V, we can paste this into a new layer. We can create a new point cloud layer internally in Global Mapper based on that more multi-step filtering process and have that ready for exporting. Which brings us finally to the last bullet on my agenda. We went through a lot of different editing tools, filtering tools, improvement tools, creating a better product. Yes, we could run with Global Mapper's analysis tools to do all sorts of terrain analysis, go through all sorts of terrain analysis procedures or extracting processes, but we'll assume for the purpose of this description that we want to capture what we've done. We know that these improvements are not applied in real time. That is not how Global Mapper works. We can retain those internally by saving a workspace, but they are just internal. If the time comes to apply these, you can export the data. Now, regardless of its format, it may be a photogrammetrically generated point cloud, maybe a point cloud you generated from a simple XYZ text file. You can export it in Lidar format, capturing all of the changes, all the modifications, all the improvements you've applied. Now, I'm just going to go to the layer and choose export. Choose the appropriate format. It's recognized the source format, so it's chosen that for me. We can go to LAS, we can go to LAS, we can go to a number of other formats as well, and other point cloud formats. But obviously, these are the most common, most widely recognized. Click OK. This is now where we create a new file. And there's a number of options in here in terms of how it's applied. Flight date will be inherited from the original. If you're generating a LAS file from a photogrammetric point cloud, obviously maybe there's no flight embedded in the data, but you can assign what that is. When did I send my drone up? You can choose a flight date and that will be embedded as well. So I'm not going to go any further with this. I'm not actually going to generate the file, but this is a kind of a useful conclusion in the workflows that we've gone through. changing the point cloud, changing its characteristics, reclassifying, maybe even changing the elevations if that's appropriate, filtering what we don't need. What we're left with, we can capture using a simple export. We have our file, we can deliver that to our client, and they will get the final product. And that, with just a few minutes over the top of the hour with apologies, is a quick snapshot of some of Global Mappers, or specifically the Lidar modules, point cloud improvement procedures. Again, if you want more detail, I do encourage you next week, we're doing a training class. We'll be looking at all of these tools and a lot more in a more practical hands-on context. So you can sign up for that one next week. Thank you, Billy, for your help today. Really appreciate you helping me walk through these workflows. I couldn't have done it alone. There was a lot of work involved in this, and delighted you took the time to help with this. And again, Billy, thank you in anticipation of helping with the training class next week as well. You'll be, if you sign up for that class, Billy and I will be working on that. Just a couple of points of note here before we wrap up. If you're not using Global Mapper currently, right there at the bottom, bluemarblegeo.com, you can download a trial copy. You can activate the Lidar module on a trial basis as well and try out some of the tools that we'll be looking at today. If you have questions related to licensing or activation, orders at bluemarblegeo.com. My colleagues in the sales side would be more than happy to help you with any questions you have. Or if you have technical questions about the software or specifically about this content we covered today, I know we went through some of the workflows very quickly. If you want some more detail, or if we weren't able to answer your question today and you want to maybe expand on that, geohelp at bluemarblegeo.com is the contact for our esteemed tech team. They would be more than happy to help you with those questions. Mention, if you would, when you send that email, that you watched this presentation so they can put your question in the appropriate context. Again, as I said at the start, we have recorded this. This will be posted in a few days. You can revisit many of these procedures, share it with your colleagues, or if you're watching the recording, obviously, again, if you have questions, you can shoot your questions to the email as noted. Thank you, folks, for taking the time. I appreciate you taking time out of your day. We will see you next month when we talk about a Global Mapper extension. Have a great day, folks.